The next question before us is the area of the triangle formed by the tangent and a normal at a given point, say 1 root 3 on the circle x square plus y square is equal to 4. There is a question, that is the area of the triangle formed by the tangent and normal to the circle at 1 comma root 3 with x-axis. This is the problem. That is the problem. So we have to understand the nature of the what is the circle? Of course, one more minute. To the circle x square plus y square is equal to 4 at 1 comma root 3 and x-axis. This is the original problem. That is the problem given. What is the circle given? X square plus y square is equal to 4. At what point tangent and normal are to be drawn? At 1 root 3. First of all, you check it. 1 root 3 is it a point on the circle? Of course, surely. 1 square plus root 3 whole square is 1 plus 3 is 4. We are happy to see and say that 1 comma root 3 is a point on the circle. What is happening here? At 1 comma root 3, both tangent and normal are drawn. What is the area of the triangle formed by the tangent, normal and x-axis? Let us view the picture. This is y-axis and this is x-axis. And this is of course the circle x square plus y square is equal to 4. At a particular point, what is the point? 1 comma root 3. A tangent has been drawn. A tangent has been drawn. Let this be the given point P1 comma root 3 and let this be the point T. Let this be the origin. From the diagram, PT is the tangent and OP is the normal, isn't it? OP is just nothing but the radius, of course. What is the radius? It is 2 units. It is 2 units. We have got this base. It is a right angle triangle, you know. Why? Because tangent and normal are at right angles from the very definition itself, by very nature itself. So it is a right angle triangle in which base is known. Now it needed to have the height, rather PT we want to know. For PT you should require T. For T you need the equation of PT. Okay. Equation of PT is x1 plus y1 is equal to r square. That is x plus y root 3 is equal to r square. Therefore, it meets x-axis at y is equal to 0. Hence, this point is 4 comma 0. X1 plus y1 is equal to 4. That is the tangent, equation of the tangent. It meets x-axis at y is equal to 0. You put y is equal to 0. X into 1 is 4. That is x is 4. And the point T is 4, 0. 4, 0 is known. Come on, friend. What is PT? Length PT. How much? 4 minus 1 is 3. 3 whole square is 9. 0 minus root 3 is root 3. Root 3 whole square is 3. 9 plus 3 is 12. Root 12 is 2 root 3. Is 2 root 3. So therefore, what is the required area? Required area of triangle OPT. I think you can agree with it that OP is a normal, PT is a tangent and OT lies along x-axis. The required area is nothing but OPT, triangle OPT, is half into base into height 2 root 3. Hence, it is 2 root 3 square units. The area is 2 root 3 so many square units. Let's say a nice question. We have entered in circles. We have made use of parabole. We have made use of ellipse and ellipse. And now we have touched a problem in which a circle is involved. Let us see one more problem in which circle is involved. In this session, we shall go through some more special problems in this heading, that is areas. The first problem is the area bounded between y is equal to e power x, y is equal to x minus x square, between the ordinates between x equal to 0 and x is equal to 1 is. Observe the problem carefully. There are two different curves, y is equal to e power x and y is equal to x minus x square. Of course, between the boundaries x equal to 0 and x is equal to 1, we need to observe the nature of the two curves given in the problem. Let us have the graph. First of all, y is equal to e power x. It meets y-axis at, if you put x equal to 0, y is equal to 1, then the curve will be like this. And if you decrease x continuously, of course, it never meets x-axis. Of course, at infinity it may be, but we don't want such things now. For the present, we need to have the curve till this point only. What is the second curve? Y is equal to x minus x square. It meets x-axis at y, x minus x square is equal to 0, x equal to 0 and 1. Therefore, it will be like this. That is the parabola, and this is the point 1. Okay, so what is the area needed here? This is the area required. That is the area required. This curve is, of course, y is equal to e power x, and this curve, of course, y is equal to x minus x square. Good. Required area is therefore equal to, required area is equal to integral 0 to 1. What is the curve which lies at the upper face? It is a power x minus lower one, x minus x square dx. Between 0 and 1. Well, this is therefore e power x minus x square by 2 plus x cube by 3 between the limits 0 and 1. Substitute the limits. This is e minus 1 by 2 plus 1 by 3 minus e power 0 minus 0 plus 0. Altogether, minus 1 by 2 plus 1 by 3 is just nothing but minus 1 by 6. Minus 1 by 6 and minus 1. Minus 1 by 6 and minus 1. Minus of 1 plus 1 by 6, that is equal to e minus 7 by 6 is the required area. E minus 7 by 6. 1 plus 1 by 6 is 7 by 6. Minus of 1 plus 1 by 6 is minus 7 by 6. So the answer is e minus 7 by 6. You see, we could find it very easy to have the answer. Why? Because we are able to know the nature of the graph. The second graph, that is y is equal to x minus x square, also meets x-axis between 0 and 1 only, at 0 and 1 only, and we are required to have the area between 0 and 1 only. Therefore, the limits of integration will also be 0 and 1 for that. The area bounded by y square is equal to 4 into 1 minus x, and y-axis is, this is the question. We are asked to find the very area bounded by the curve and y-axis, that is, we are supposed to have, or we are supposed to calculate the area along y-axis. So we need to have a formula of x in terms of y. Let us do that first. Y square is equal to 4 into 1 minus x. that is y square is equal to 4 minus 4x, or 4x is equal to 4 minus y square, or x is equal to 1 minus y square by 4. By 4. Moreover, it is necessary for us to know the points where that curve meets y-axis, isn't it? Also, y square is equal to 4 into 1 minus x meets y-axis at y square is equal to 4, isn't it? 1 minus 0. On y-axis, x is 0, x coordinate is 0, so y square is equal to 4, or y is equal to plus or minus 2. Therefore, the required diagram is 0 comma minus 2, 0 comma plus 2. This is the area required. That is the area required. Therefore, required area is equal to integral minus 2 to 2 x dy. That is integral minus 2 to 2. What is x? 1 minus y square by 4 dy. You see, again it is an even function, or by following the symmetry, this can again be taken as 2 into integral 0 to 2 1 minus y square by 4 dy. By getting the integral very simply and substituting the limits, we will have the answer like this as 2 into y minus y cube by 12 between the limits 0 and 2. Isn't it? For 1 it is y, for y square it is y cube by 3, already by 4 is there, hence it is y cube by 12, y cube by 12. So, this is equal to 2 into, you first of all put 2 for y, 2 minus 2 cube by 12, 2 minus 8 by 12 minus 0. What is 8 by 12? It is 2 by 3, 2 fours, 3 fours, 2 by 3. 2 minus 2 by 3 is 4 by 3. 4 into 2, 8 by 3. So, the ultimate answer is of course 8 by 3 in square units. In square units. Let us look at the next question, which looks so lengthier in its data. Of course, it's very simple if you make an attack. Try to follow the sense given by the sentence in the question carefully. The area of the triangle, okay, a triangle is going to be formed in the problem. Formed by intersection of a line parallel to x-axis passing through HK. What is the general form of a line parallel to x-axis? Y is equal to something, but it passes through HK. So, the very first line is y is equal to k. With the lines y is equal to x and x plus y is equal to 2. This area is 4h square. That area is 4h square. Then the locus of P is, first of all, you have to find the area of the triangle formed by those three lines and equate it to 4h square. How to get the area? Let us first of all find the vertices of the triangle. Good. These two meet at KK. KK. These two meet at, in the place of y, x plus x, 2x is equal to 2 at 1 comma 1. These two meet at KK. These two meet at 1 1, and these two meet at, if you place y as k, then x is equal to 2 minus k at 2 minus k and k. You could have followed, it seems. Those are the vertices of the triangle, isn't it? Clearly, k, k, 1, 1, 2 minus k, k are the vertices. Area of the triangle formed by these 3 points is 4h square according to the data. Therefore, what is the area? Half into, come on, k minus 1, k minus 1, k minus of 2 minus k minus 2 plus k. It is 2k minus 2, k minus k, 0. Isn't it? K minus 1, k minus 1. K minus of 2 minus k is k minus 2 plus k, that is 2k minus 2, and k minus k is 0. What is the area? Half into 0 minus of 2 into k minus 1 whole square is just nothing but k minus 1 whole square. Actually, delta is observed to be k minus 1 whole square. You see, this area, but this area is equal to 4h square. So, k minus 1 whole square is equal to 4h square, isn't it? Therefore, k minus 1 is equal to plus or minus 2h. Okay, k minus 1 is equal to plus or minus 2h. Therefore, locus of h comma k is y minus 1 is equal to plus or minus 2x. That's all. Yes, very simple problem which needs no graph at all, which needs no representation at all. Very simple estimation, and the clue here is you are supposed to have the vertices of the triangle, so that you can estimate the area of the triangle immediately on the spot like this. It is k minus 1 whole square, and you are supposed to equate this area, that is k minus 1 whole square, to the given number 4h square. You equate it, k minus 1 is equal to plus or minus 2h, hence the locus of h comma k is y minus 1 is equal to plus or minus 2x. Of course, it is a pair of straight lines. One is y minus 1 is equal to 3x, and the other is y minus 1 is equal to minus 2x. That's all. That is the required locus. The next problem is ready on the board. Let us have a look over that. He has given two curves here. One is, the equation of curve is like that. Maximum of mod x and mod y is equal to 1. That is one locus, and the other is a circle, of course, pi of x square plus y square is equal to 3. Is right? Maximum of mod x and mod y is equal to 1. Mod x and mod y is equal to 1 means this locus is just nothing but a square whose vertices are plus or minus 1, plus or minus 1, plus or minus 1. That is 1, 1, minus 1, 1, minus 1, minus 1, 1, minus 1. Wherever you go, maximum of mod x and mod y is 1. So this is the locus. Okay, this is the curve, and the other is pi of x square plus y square is equal to 3. That is x square plus y square is equal to 3 by pi. X square plus y square is equal to 3 by pi. That is, of course, the circle. X square plus y square is equal to 3 by pi. 3 by pi. What is pi actually? What is pi? 3.14 and something. So 3 by pi is less than 1. So radius of the circle is less than 1. Hence that circle lies inside of this. This is the circle. That is the first one. That is the second one. What is the area required here? Bounded between these two. So the shaded portion is, of course, is the required area, isn't it? Here also, we must be able to know the nature of the graph. Yes, of course. This area we must find, require, we need to have the area. It's very simple. You see, this is a square with the length of each side as 1 unit or 2 units? 2 units. This length is 1, this length is 1, so it is 2, 2, 2, 2. Area of the square is 2 into 2, that is 4, minus area of the circle, isn't it? Required area is equal to area of the circle, area of the square minus area of the circle. What is area of the square? 2 square, that is 4. What is area of the circle? Pi r square, that is pi into r square is 3 by pi. Pi and pi will go away, leaving you 2 square is 4, 4 minus 3 is 1. So, what is the required area? 1 square unit. 1 square unit. That is the beauty of the problem. You must be able to notice that this is nothing but a square with what says plus or minus 1 plus or minus 1. And of course, the length of each side of that square is 2 units with this area 2 square minus area of the circle. Pi into x square plus y square is equal to 3 means x square plus y square is equal to 3 by pi. There itself we will conclude that that circle is inside the square, because radius is absolutely less than length of this side, half of this side. So that, or rather, diameter is less than the length of each side, whatever you see. So the required area is 1 square unit. Another beautiful question is there we are going to look at. In that question he says that there are 2 circles of unit radii. Radius of the first circle is 1, radius of the second circle is also 1, and they cut each other orthogonally. They cut each other orthogonally. Automatically, some intersected portion will be there. We are supposed to catch, we are supposed to know the area of that region of intersection of those 2 circles. That is the question. What is the question? 2 circles of unit radii, 2 circles of unit radii cut each other orthogonally. Then area of their intersection is this much. He is asking us. Okay, then let us first of all draw the diagram or graph as you like. He has not given the equations. He has not given the equations, but of course they are of radius 1 unit each, and they cut each other orthogonally. That is the point given in the hypothesis. We shall make use of that to have the needy diagram. Come on, please observe the diagram. Let C be the center of the first circle and D be the center of the second circle, each of radius 1 unit. They cut each other orthogonally. Hence, this angle is 90, this angle is 90, this angle is 90, this angle is also 90. Yes. And the area of intersection is required. That is the area required. Well, let us first of all have a good plan of obtaining it. Later on you can implement it. Okay, you keep that figure there itself. Let us have a rough figure like this. This area we want. This is C, this is D, this is A, this is B. Let me call this X, this Y, this Z. What is the heroine of the problem? X. We want X. Okay, I like to find that X like this. You please follow me. Area of required area is equal to area of the sector ACB plus area of the sector ADB minus area of the square ACBD. Is this plan correct or not? Let us see. First step, area of the sector ACB. What is the area of the sector ACB? X plus Y. Next, area of the sector ADB. What is ADB? X plus Z. Minus area of the square ABCD. Mottam. Totally. The total area is X plus Y plus Z. Isn't it? X plus Y plus Z. What is going to happen? 1x, 1y, 1z, leaving you x, which is required. Isn't it? This is the plan of obtaining the area of intersection, or rather the common area of the two intersecting circles is supposed to be obtained like that. And this is the plan, which is the proper plan to have the area, isn't it? Okay, first of all, what is the area of this sector? This sector ABA. Actually, for finding the area of a sector, there are so many formulae. One of them is r square theta. Half r square, LR by 2 is there, half LR, but L is the length of the R, that is nothing but r theta, so it is half r square theta. So for the sector ACB, half into r square is 1 square into theta. Angle between the two radii of the sector is nothing but pi by 2, plus area of the sector ADB, absolutely the similar, that is half into 1 square into pi by 2, minus area of the square ABCD. What is that? 1, 1, 1, 1 the square, with each of the side is 1, hence its area is 1, 1 square. So this is, what is that? Pi by 4 plus pi by 4. What is pi by 4 plus pi by 4? Pi by 2. Pi by 2 minus 1 is of course the required area. That is the beauty of the problem. Observe it carefully. Look at the next question. It is readily available for us. For what values of M is the area bounded by the two curves y is equal to x minus x square and y is equal to mx is equal to 9 by 2. There are two curves, of course. Surely there is some area bounded between those two curves. You are supposed to equate that area to 9 by 2 and find the value or values of M. Okay. To have the answer perfectly, let us imagine the graphs. Y is equal to x minus x square. It is a parabola opened downwards whose axis is parallel to y-axis, and it meets x-axis at x minus x square is equal to 0, x into 1 minus x is 0, so x is 0 or 1. Hence, we can imagine the nature of the graph of the parabola y is equal to x minus x square. It looks like this. This is 0 and this is 1. Okay, y is equal to mx. That is a straight line, of course, passing through origin. This is y is equal to mx. And we want to have the area between them. So for that, we must be able to know this point. Then only you can have the limits of integration. Therefore, the very first duty is you have to know the point where these two curves meet. One thing is sure, at origin both of them meet, no doubt. Other point, what is the other point which looks like, say the point A in the graph? We are now ready to have A. How? Just solve them. Y is equal to x minus x square and y is equal to mx meet at x minus x square is equal to mx. If x is 0, the y is also 0. 0, 0 is one point of intersection. It is clearly visible, of course. And we are interested to know the other point of intersection. And to find that, let us take it for granted that x is not equal to 0. So that you can cancel x here. 1 minus x is equal to m, or x is equal to 1 minus m. X is equal to 1 minus m. Therefore, what is this point? 1 minus m comma 0. Isn't it? Okay. The things are very clear, crystal clear before us. Yes. What is the required area? Area under this curve minus area under this curve. This is f of x, this is g of x. Isn't it? Therefore, required area is equal to integral 0 to 1 minus m. Come on friend, which curve lies at the upper place? Parabola or the straight line? Parabola. What is the parabola? X minus x square minus straight line mx dx. What is it? For x it is x square by 2. For x square it is x cube by 3. For mx it is mx square by 2. Between the limit 0 and 1 minus m. This is the area which we could find actually. And according to data, he has given that this area is equal to 9 by 2. So, this is supposed to be equated to 9 by 2. Of course, we are supposed to have the values of m. Well friend, I like to remove the diagram because I can utilize that space for calculation. You please observe the diagram. If you say okay, I shall remove it. Well done. This is x square by 2 minus mx square by 2, isn't it? So, x square by 2 into 1 minus m minus x cube by 3 between the limit 0 and 1 minus m is equal to 9 by 2. First of all, substitute 1 minus m. What happens? 1 minus m whole square into 1 minus m, 1 minus m whole cube by 2 minus 1 minus m whole cube by 3. And if you put x equal to 0, everything will be 0. So, this is equal to 9 by 2. 9 by 2. Well, if you take 1 minus m whole cube out, it will be 1 by 2 minus 1 by 3 is nothing but 1 by 6. Therefore, 1 minus m whole cube is equal to 9 by 2 into 6. Why is it so? It is 1 minus m whole cube into 1 by 6. This 6 is sent to that side. So that it is 27. This is 27. 54 by 2 is 27. Therefore, 1 minus m is equal to 3. 27 power 3. Therefore, m is equal to minus 2. M is equal to minus 2. M is equal to minus 2. 1 minus m whole cube is equal to 27. Therefore, m is equal to minus 2. Is the suitable answer? Is the suitable answer? Find the area between, bounded between y square is equal to x and y is equal to mod x. He is saying, okay, what do you mean by y square is equal to x? It is of course a parabola. Y square is equal to x. Y is equal to mod x. What do you mean by that? Y is equal to x or y is equal to minus x. So, the graph of y is equal to mod x is, the graph of y is equal to mod x is this V-shaped diagram. Luckily, we are not at all interested to deal with this because it has no intersection at all with y square is equal to x except this point. Therefore, the required area is this. And to evaluate this area, we must be knowing this point. So, we need to have this point. What is this point? Y square is equal to x and y is equal to x meet at x square is equal to x. That is x into x minus 1 is equal to 0. That is x equal to 0 and x is equal to 1. If x is equal to 1, automatically y is also 1. Then this point is 1 comma 1. This is 0 comma 0. Even though he has given y is equal to mod x in the data, the line y is equal to minus x, of course, is not suitable and not useful at all here. And this part, this region, area of this region is only required here. So the required area is equal to integral 0 to 1. What is the curve which lies at the upper place? Is it the parabola or the straight line? It is the parabola. What is the parabola? Y square is equal to x, or y is equal to root x minus y is equal to x dx. Okay, then what is the integral of root x? 2 by 3 into x power 3 by 2 minus x square by 2 between the limits 0 to 1. If you substitute 1 here, 1 power 3 by 2 is 1, so it is 2 by 3 minus 1 by 2 is of course the answer. It is 4 by 6, this is 3 by 6, so it is 1 by 6. What is the LCM? 4 minus 3 is equal to 1 by 6. So the required answer is 1 by 6. So even then some modulus involvement is also there in the data. You just have the intersection. Whose intersection is needed? Which region is needed? What are all the points of intersection in that region? What are the limits to be taken? These are the things that must be kept in mind to have the answer. Here the answer for this question is 1 by 6. The next question before us is find the area. Find the area bounded between x square is equal to 4y plus 4 and the line 3x plus 4y is equal to 0. The line 3x plus 4y is equal to 0. We know everything about x square is equal to 4y plus 4. Of course, it is a parabola. It is a parabola whose axis is on y-axis, and this is x square is equal to 4 into y plus 1. 4 into y plus 1. So that it has the vertex at 0 minus 1 and it meets x-axis at minus 2 or plus 2. Hence, this is the parabola. This is 2, 0. This is minus 2, 0. This is 0, minus 1. This is about x square is equal to 4y plus 4. And 3x plus 4y is equal to 0 and x square is equal to 4y plus 4. When and where do they meet? That is the special case of investigation now. That only offers you the correct way to guess the answer. Look here. X square is equal to 4y plus 4 and 3x plus 4y is equal to 0. Meet at, in the place of 4y you can write minus 3x, or x square plus 3x minus 4 is equal to 0 implies x plus 4 into x minus 1 is equal to 0 implies x is equal to minus 4 or x is equal to 1 or x is equal to 1. Hence, like this it meets. So here x is equal to minus 4, here x is equal to 1. X is equal to 1. So the required area is between minus 4 and 1. What is the curve which lies above of these two? Line or parabola? Line. And then the parabola. Therefore, required area is, we could have got the correct plan of integration and the correct limits of integration also. They are between minus 4 and 1. Yes, of course. And the thing to be integrated is integral minus 4 to 1, equation of the line, y from the equation of the line and y from parabola. Yes. Therefore, required area is equal to integral minus 4 to 1. What is y from this? Minus 3x by 4, isn't it? Minus 3x by 4 minus, what is y from this? X square minus 4 by 4. X square minus 4 by 4 dx. Therefore, it is integral minus 4 to 1 minus 3x by 4 minus x square by 4 plus 1 dx. Am I right? Okay, then this is therefore minus 3 by 4 and x square by 2 minus 3 by 8 into x square between the limits minus 4 and 1. This is x cube by 3, altogether x cube by 12 minus 1 by 12 into x cube between the limits minus 4 and 1. This is x, isn't it? X between the limits minus 4 and 1. Minus 3 by 4 into x square by 2, that is minus 3 by 8 x square, minus 1 by 4 into x cube by 3, minus 1 by 12 into x cube. This is x between the limits minus 4 and 1. So totally it is minus 3 by 8 into 1 square minus minus 4 whole square, minus 1 by 12 into 1 cube minus minus 4 whole cube plus 1 minus minus 4. Altogether this is 1 minus 16 is minus 15, minus minus of minus is plus, 15 3 is of 45, 45 by 8. 1 minus of minus 64 is 1 plus 64, that is 65, 65 by 12, and the last one is 5, which is the LCM. 24 is the LCM. 3 times 3 45s are 135 minus 130 plus 24 5s are 120. This is 5 plus 120, 125, 125 by 24, so many units. That is the area. There is the required area. Here also, the planning about the graph is essential. This plays the vital role. Follow this. The next problem is, we are supposed to find the area bounded between these two parabolas, x plus 2y square is equal to 0 and x plus 3y square is equal to 1. And the equation of each curve itself offers us an idea to have the area along the y-axis. Why? Because it is quite easy to get x in terms of y. X is equal to minus 2y square and x is equal to minus 3y square, isn't it? And this is of course a parabola which is open towards left. There is also a parabola open towards left, but this vertex of this parabola is horizon, whereas it is not that. Therefore, they might be in this shape. In that particular shape they might be. Therefore, the area between them is required. So both are parabolas open towards left. Open towards left. These two meet at from this x is minus 2y square. From that x is 1 minus 3y square. Send minus 3y square to this side, y square is equal to 1, therefore y is equal to plus or minus 1. Y is equal to plus or minus 1. And of course, if y is 1, x is minus 2, isn't it? 1 point. If y is s, x is minus 2 plus or minus 1. Okay, and as we are interested to find the area along y-axis, required area is integral minus 1 to 1, which curve lies ahead of another. this curve. Therefore, from this x is 1 minus 3y square minus from this x is minus 2y square dy. Therefore, this is minus 1 to 1. 1 minus 3y square plus 2y square is 1 minus y square dy is equal to 2 into integral 0 to 1, because it is an even function, 1 minus y square dy. 1 minus y square dy. Hence, this is y minus y cube by 3 between the limit 0 and 1. So, this is 2 into 1 minus 1 by 3, 2 by 3, that is 4 by 3 is the answer. The required answer is 4 by 3. The next question before us is, find the area bounded by the curve root x plus root y is equal to 1 and the coordinate axis. And the axis. Where does this meet x-axis? At x is equal to 1. Where does this meet y-axis? Y-axis means y is equal to 1. Therefore, the curve will be like this. This is 1, this is 0. A very, very simple diagram. What is the required area? It's very simple. This is the required area. That is the required area. Of course, the required area is straight away integral 0 to 1. Come on, x dy or y dx? Y dx. What is y? Root y is equal to 1 minus root x, isn't it? So, 1 minus root x whole square dx. Hence, it is integral 0 to 1. 1 plus x minus 2 root x between the limits 0 and 1. Altogether, this is x plus x square by 2 minus 2 into, what is the integral of root x? 2 by 3 into x root x between the limits 0 and 1. Okay, then what is the answer? 1 plus 1 by 2 minus 4 by 3, isn't it? Isn't it? 2 to 4 by 3. 2 into 2 by 3 is 4 by 3. We are substituting 1 in the place of x, that is, we are using the upper limit in the beginning. Minus, if you put x equal to 0, ultimately it will be 0. Hence, this is 3 by 2 minus 4 by 3. LCM is 6. 9 minus 8 is 1 by 6. So, here also, again, the answer has become 1 by 6. Go through that. A lengthier sentence, a lengthier question, but a very, very simple answer. As in this problem, already solved problems which were famous results are to be used. Let us now recall two important results which we could already discuss with. One is y square is equal to 4ax and its lattice rectum. What is the area? 8a square by 3. Another, y square is equal to 4ax and the double ordinate x is equal to k. What is the answer? This is, what is the area? 8 by 3 into root a into k root k, isn't it? It's very simple. If you replace k by a root a into root a is 8a square by 3, the same old answer is that. These two are very, very famous and useful results. We shall now make use of those two results, of course. to have the answer for this question, you try to follow the sentences carefully, find the essence of those sentences. The area bounded by y square is equal to 4x and the double ordinate x equal to 6 is twice the area bounded by y square is equal to 4x and its lattice rectum. So he means this area is twice this area. In such a case, find the lattice rectum. Okay, what is the double ordinate given? X equal to 6. So in the second formula, in the place of k, what are we having here? 6. Therefore, without drawing any graph, without finding any point of intersection, without finding any limits of integration, no question of using integration. We shall use directly these two answers. That answer is 8 by 3 into root a into k root k means 6 root 6. Am I right? Is twice the area, 2 into 8a square by 3. 8a square by 3. 8 by 3. 8 by 3. And root a six root 6, 2a into a root a, 2 root a into a root a, root a, root a, 2, 3. Square it on both sides. 9 into 6 is 54. A square into a is a cube. Therefore, a is equal to 54 power 1 by 3. That is 27 into 2 power 1 by 3. That is 3 into cube root of 2. Well, my dear, this is a. But what is required here? What is required here? We're not supposed to have the value of a, but we are supposed to have the length of the lattice rectum. What is the length of the lattice rectum? It is 4a. What is that? 4a. Therefore, length of the lattice rectum of the parabola, that is LLR, let me abbreviate it as LLR. Length of the lattice rectum is 4a, hence it is 12 into cube root of 2 is the answer. How beautiful they are. Imagine. Unless you know them, it becomes a tedious job to find that area and this area separately and equate them. So, maximum time has been saved for us because we could already know these two. We could already know these two. We could have calculated. We could have kept them in mind in our memory box. They are useful results. Reusability of the results is there. That is why the length of the lattice rectum is of course 12 into cube root of 2, so many units. This is the beautiful question before us. The next question is, the area bounded between the two parabolas y is equal to ax square and x is equal to ay square is 1. Find the value of a, he is saying. Find the value of a, he is saying. Think of the problem. There are two parabolas, y is equal to ax square and x is equal to ay square. Its area is, the area bounded between them is 1. Well, let me take this as x square is equal to 4by, where 4b is equal to 1 by a. Am I correct? And this is y square is equal to 4ax, where 4a is also 1 by a. We know that area bounded between these two is 16ab by 3. 16ab by 3. 16ab by 3. And from data, from the information, given information, the area bounded is 1. So 16ab by 3 is equal to 1. Therefore, 4a into 4b is equal to 3. Am I right? 4a into 4b is nothing but 16ab is 3. But you see, what is 4a? 1 by a. 1 by a into 1 by a is equal to 3. So a square is equal to 1 by 3. A square is equal to 1 by 3. Hence a is equal to plus or minus 1 by root 3. What is the value of a? Plus or minus 1 by root 3. Here also, in solving this question also, we could have made use of this formula 16ab by 3. We know that the area bounded between the parabolas y square is equal to 4x and x square is equal to 4by is 16ab by 3. I think you could recollect it. You could remember it. Yes, 16ab by 3 is the area according to the formula, and the area is 1 according to the data in the given item is 1. So 4ab into 4ab is 3. But 4a is nothing but 1 by a. 4b is also 1 by a. Hence 1 by a into 1 by a is 3. That is a square is 1 by 3, or a is equal to plus or minus 1 by root 3 is the right answer. So it is quite beneficial, of course, to know the standard results as formulas. Please mind this. A beautiful question, really a beautiful question is before you. Follow it carefully. The area bounded by the curve y is equal to f of x axis, x is equal to 1 and x is equal to b is b minus 1 into sine of 3b plus 4. Then what is f of x? Then what is f of x? Okay, let us make use of the data carefully. Integral 1 to b f of x dx is equal to b minus 1 into sine of 3b plus 4. Am I correct? Come on friend, tell me an idea. You think of differentiating with respect to b, treating b as the variable you differentiate with on both the sides. Here, by making use of the Lagrange's rule of differentiating a definite integral, this is nothing but f of b, isn't it? F of b is equal to, come on, u derivative into v plus v derivative cos of 3b plus 4 into 3 into u b minus 1. This is therefore equal to 3 into b minus 1 into cos of 3b plus 4 plus sine of 3b plus 4. Well, my dear, this is f of b. What is required actually? We require f of x. You just replace b by x. What are you having? 3 into x minus 1 into cos of 3x plus 4 plus sine of 3x plus 4. Fantastic, unbelievable, isn't it? How easily we are able to get the answer for f of x. No question of drawing any graph or finding the limits or any other thing. Of course, here you could have made use of Lagrange's rule of differentiating a definite integral. You please don't forget that. According to that only, we are able to have f of x. This is the question. Beautiful question.